Hi everyone, this is NB. In this video, we are going to solve a problem which is very famous, nth Fibonacci number. We will solve the nth Fibonacci number problem using memorization and recursion. Without getting late, let's get started. Before going to the nth Fibonacci number, we should know about Fibonacci series. A Fibonacci series is a series generated using the previous two elements sum. The first two elements are 0 and 1. You can ignore this 0 also, but anyway, we will consider that 0 too. The first two numbers are 0 and 1. The next number is generated using the previous numbers 0 plus 1. And again, the next number is generated using the previous two numbers 1 plus 1, which is 2. And the next number is 1 plus 2, which is 3. And the next number is 3 plus 2, which is 5. In this way, we can generate Fibonacci series. So, coming to the problem, we need to print nth Fibonacci number taking the n value from the user. So, first, we will take a number n is equal to int of input. We will pass that parameter to the fib function. The base case is n less than 2. When n is less than 2, the function returns 1 because first digit of Fibonacci series is 1. If you pass 1 as parameter, as the base case is true, n is less than 2, 1 is less than 2, right? So the function returns 1. If you pass 2 as parameter, as base case is not working, it goes to this statement return fib of n minus 1, fib of n minus 2. Fib of n minus 1 is 2 minus 1, which is 1. Fib of 1 is again called. Fib of 1 is fib of 1 returns 1. So here it comes 1. And fib of n minus 2, 2 minus 2 is 0. Fib of 0 satisfies the base case and returns 0. So 1 plus 0 is 1. Fib of 2 becomes 1. So what is the problem with this recursion method? First, suppose start giving a value to the input. Let the number be 10. The 10th Fibonacci number is 55. And try to execute again with a larger number. Let's say a 28. The nth Fibonacci number is 317811. And try to execute the same program with more larger number. Let's say 55. After so much time, you can get the output because recursion is not an efficient solution for Fibonacci series. For that purpose, we need to use memorization technique to solve this Fibonacci series problem. So, how do we do that? We will modify the above problem with small changes. Declare a dictionary with F and write the same program as it is, but there are two cases. One is base case and the second one is if the number is already exists, we need not to call the function fib of n minus 1 plus fib of n minus 2 because we already store that value. The best technique to use recursion efficiently is to use memorization technique. What is memorization technique? We generally use this technique to memorize the solutions which are already obtained. For example, let's say you want to find out 4th Fibonacci number. What happens? We will see the execution procedure. First, Fibonacci 4 is called. Here, n is 4. The first time the iteration does not go to the base case because n is greater than 2, right? So, next, fib of n minus 1, which is fib of 3 plus fib of 2. First, it calls fib of 3. One fib of 3 is called, which is not satisfying the base case, right? So then it again calls fib of 2 plus fib of 1. The function again calls fib of 2 first. Fib of 2, which is not less than 2, right? So fib of 1 plus fib of 0. Again it calls fib of 1, which is a base case, right? So which returns 1. Here it returns 0. So the answer is 1. This 1 is returned to this fib of 2. Here the value becomes 1. And next fib of 1 is called. As fib of 1 is called, the value returned by the function is 1. And next this again fib of 2, fib of 1, the result is 2. So fib of 3 is 2. And fib of 2 is called. Once fib of 2 is called, it again calls fib of 1 and fib of 0. And the result is 1. So the answer is 3. Fib of 4 is 3. You can see that fib of 0 is executed more than one time, and fib of 1 is also executed more than one time, and even fib of 2 is executed more than one time. In order to reduce these repetitions, we need to use memorization technique. How it helps? When we first call fib of 1, we will store fib of 1 value in a dictionary using 1 as key. When it calls fib of 2, we store fib of 2 value with 2 as key. In this way, we will store all the values which are got for the first time. And the next time, whenever you ask fib of 2 or 1, it will return very fastly as it is already stored. So how do we store? Declare a dictionary F and include a new case to the base case. If n in f dot keys. If n is already existed in the dictionary as key, then return f of n. Otherwise, execute the next statement. You store f of n as fib of n minus 1 plus fib of n minus 2 and return f of n. First, suppose you are calling for fib of 4. It start executing fib of 3 and again fib of 2 plus fib of 1, which is fib of 1 plus fib of 0 is executed. Once fib of 1 is found, fib of 2 got the result as 1 and fib of 1 will not call, because fib of 1 is called, it directly returns f of n because fib of 1 is already stored in the dictionary. And next it calls fib of 2 and again it returns fib of 2 immediately because fib of 2 is already stored. In this way, we can improve the efficiency of the program using memorization. Now start executing the program with fib of 10. The 10th Fibonacci number is 55, which is 55. Take a larger number, let's say 28. The answer is 317811. Take more bigger number, let's say 55. In the first case, you haven't got this output because you haven't used any technique like memorization. You just used recursion. That's why it is not efficient. Even this memorization technique is efficient for till 558 also. So you got the output. But by using just recursion, you cannot achieve this. Memorization is the best technique which can solve many problems while using recursion. If you enjoy this video, a sub to the channel would be amazing.